What is up, guys? Welcome to Barden. My name is Heinrich. In the last episode, we made it so that our enemy can detect our player when we come within a certain range of him. So, like this. The enemy sees us. We can move around a little bit. If we leave another certain range, the enemy will go back to moving. Now we're going to take a look at how we can make it charge at the player and also
look for player state.
So let's first start with the charge state. So as you can see, when the player has been detected, if it is in range for a certain amount of time, we're going to transition to the charge state, in which we're just going to speed up the movement speed of the enemy in the direction of the player. So let's jump into Unity and stop this. Head to our files, and then let's get started. Let's head to our scripts folder, enemies, and then states. And then now let's create a new C# script, and this is going to be our charge state. Let's just go ahead and open that up. Okay, and then let's go to our data folder and let's create the data class for this state. So d_charge state, like that. Open that up. Okay, head back to the enemies folder, and then let's go into the enemy specific folder, enemy1, and let's create the e1_ charge state, like that. And let's open that up as well. Okay, so we have our charge state, which I realize I accidentally named charge instead of charge state. So let's just add state in here. Oops. Save it. Then we just need to close it. Go back to Unity. Go back to our states folder and then rename it here as well, which is kind of annoying, but that's okay. And let's open that back up. Okay, so we have our charge state script, our enemy1 charge state script, and then we have our data script. Let's start with the charge state. We'll get rid of all the pre-generated code, then change it to inherit from state instead of mono behavior. And then we can generate the constructor, just like that. Okay, now let's get a reference to the state data. So it's going to be protected and d_charge state called state data. Add it to the constructor, so d_charge state data. And then inside the constructor, we say this dot state data equals state data. And then let us generate the function overrides. Untick the first three, click OK. So when the enemy charges at the player, we just need a different movement speed. So let's come to our charge state data script and then get rid of this code, make it inherit from scriptable object. And the first thing we're going to need is a public float charge speed. And by default, let's just set it to something like 6. 6 sounds good to me. So now back in charge state, all we need to do is in our enter function, we will start off by calling entity.setVelocity, and we're going to set it to state data.charge speed, like that. So what I want to do is I want to make it so that the enemy charges at the player only for a certain amount of time, and then when that time is up, we will go back to either the player detected state if the player is still in range, or we'll go into a different state. So let's actually add in our d_charge state script, let's add a public float, and we'll just call it charge time, and let's just make it 2 seconds to start off with. So if we take a look at our state machine diagram again, we can see that in our charge state, we want to either transition back to player detected if we've charged for a certain amount of time and the player is still detected, or we want to go to the player attack state if the player is in range to be hit. So let's start with getting everything we need for this transition back to player detected state. We want to transition back to player detected state if the character is still within the minimum aggro distance. So in our charge state script, let's create a protected bool, and we'll just call it is player in min aggro range like before, and let's immediately come and set that in enter. So is player in min aggro range equals entity dot check player in min aggro range, like that. And then let's copy that and put it in our physics update as well. When the enemy is charging at the player, we also don't want it to keep charging once it reaches a ledge or a wall. So let's add those booleans in here as well. So we'll say protected bool is detecting ledge, like that, and protected bool is detecting wall. And let's immediately come and set both of those as well. So is detecting ledge equals entity dot check ledge, and is detecting wall equals entity dot check wall, like that. And then just copy and paste both of those in our physics update. Okay, so I just realized that I'm doing something really dumb. Why would I call these three functions in physics update and in enter? Because that means if I need to change something, I need to remember to change it in both of these. So let's actually quickly change this so that we have one function where we can put all these calls in there that gets called in enter and physics update for all of our states. Now this part I did not plan out, so we're doing this on the fly. Let's see how it goes. So let's go to our state class. If that is still open, it is not. So we'll go back to Unity, go to scripts, enemies, states, no, enemies, state machine, open up our state class. And let's just add another public virtual void function here. And we'll just call it do checks, something like that. Now in this function, we'll just write those functions that we need. And then while we're here, we can just call do checks from enter. So do checks, and then we can also call do checks in our physics update. So do checks, like that. Okay, let's fix our move state and idle state so long. So go to move state. We can click on the move state name, control full stop, generate override. And now we just want our do checks function. It adds it up here. So we can just cut this code from enter and put it in here, like that, and then remove it from physics update. Looks good to me. Let's do the same with our idle state. So idle state, click on the name, control full stop, generate overrides. We want the do checks one. Do that. And in here, we're just checking for the player in the min aggro range. So let's cut that, put that in do checks, and then remove it from our physics update. Like that. Okay, and then next we have our player detected state. And do the same once again. So generate override. We just want that one. Cut these checks, put them in there, and then remove them from our physics update. And this may seem like a little bit of extra work now, but again, we're doing all of this to make our lives easier. So now finally our charge state. We can do that again. Control full stop, generate overrides, do checks, put this in here, and remove it from our physics update. Now before we go on, let's head back to Unity and make sure we did all of this correctly. So the enemy should still, so he's still moving, so everything's working there. He's detecting the ledges. He detects us. Perfect, everything works. So now when we create a new state and we generate our overrides, this do checks function is going to be there for us. we don't have to remember to call it from enter or from the physics update. Perfect. Now I need to remember where we left off. So we're busy checking to see if the player is in the minimum aggro range, and then we want to transition back to our player detected state once the time has run out. Okay, so let's create another boolean for the charge time, and we'll just call it is charge time over, and then in enter we just need to make sure we set this to false, like that. And then in our logic update, what we're going to say is if time.time is greater than or equal to start time, which again, remember start time is a property that all our states have, plus our state data dot charge time. If this is true, then is charge time over equals true. So we'll use this boolean to determine when we need to transition to a different state. So we can save this, and then let's head to our E1 charge state class. We can get rid of the code, and this time we make it behavior from charge state, like that. Now we can generate our constructor, and then we add the reference to our enemy1. So private enemy1 enemy, add it to the constructor, enemy1 enemy, and then in the constructor we say this dot enemy equals enemy, and now we can generate our overrides. And it's not quite necessary to generate all of these if you don't want to. I just like having all of them there, but for the most part we don't add any extra code to a lot of these. In this case, for the enemy specific classes, we generally only add code to the logic update to decide which states we go to. So now in our logic update we can say if is charge time over, then depending on if we are detecting the enemy or not, we're going to transition to different states. So in here we'll say if is player in min aggro range, then state machine dot change state to enemy dot player detected state, like that. So when we are charging, once we've charged for a certain amount of time, if the player is still detected, we will go to the player detected state. Now if we look at our state diagram here, there's actually supposed to be another transition from charge state to the look for player state. So if we have finished the charge time and the player is not in range and is also not detected, we will go to the look for player state. But we'll worry about that later. For now, we still need to make it so that we can go from our player detected state to our charge player state. So back in our code, let's go take a look at our player detected state. We didn't add much to this yet. So when the player is detected, we want to wait a certain amount of time and then charge at the enemy. So we need to declare a wait time. So let's go to our dPlayerDetected class. Which is here. And in here, we're going to declare a public float that we're just going to call action time. Because from the player detected state, depending on which enemy we have, we might not go to a charge state, but we're just going to say after the player has been detected for a certain amount of time, perform whatever action we assign to it, which in this enemy's case is going to be to charge at it. And by default, let's just set that to 1.5f. Whoops, like that. So now in our player detected state, and another thing I should mention is we're going to have two sorts of actions when the player is detected. We're going to have a long range action, and we're going to have a close range action, or short range action, whatever you want to call it. Basically, in this case, for this enemy, the long range action is going to be to charge at the player, and the short range action is going to be to attack the player. So if the player is detected and he's really close, we will immediately attack the player. In the case of the other enemy, our long range action is to fire an arrow, and our short range action is to jump away. So for now, let's start with the long range one. So let's create another protected bool that we will call perform long range action, like that. And now the condition for performing the long range action is going to be set in logic update, where we will say if time.time is greater than or equal to start time plus our state data dot action time, like that. And it might be better to name this long range action time instead of action time. So if we click on action time and press Ctrl R twice, we can rename it and it'll rename it everywhere for us. So long range action time, like that. And now inside of this if statement, we can just say perform long range action equals true. And we just need to remember in enter to set this to false. So perform long range action equals false. Cool. So now if we go to our E1 player detected class, so currently we're saying if the player is no longer in the max aggro range, we go to idle. But instead, what we want to say is if perform long range action, then state machine dot change state to enemy1 dot charge state. Although we have not yet declared the charge state on our enemy1 class, so this isn't going to do anything, but we'll take care of that just now. We just need to remember to remove this line as well, like that. Cool. Okay, let's go to our enemy1 class and let's create the state. So we'll say public E1 underscore, and we're creating a charge state, and we'll just call it charge state. And then we can create the public getter and the private setter for it, like that. Let's create a reference to the data. So serialize field, private d underscore charge state, and this is our charge state data, like that. And then let's call the constructor from start. So we'll say charge state equals a new E1 underscore charge state. Again, this state machine, the Boolean name is going to be charge. And let's remember to pass the data this time. So charge state data, and this as our enemy1, like that. So now if we go back to our E1 player detected state, the error is gone. Let's go back to Unity. And now the first thing we need to do is create the animation for the charge state. So let's pull up our animation window, click on our alive game object, create a new clip, navigate to the animations folder, enemy, and we'll call it enemy1 underscore charge. Now for this animation, I'm going to use the same sprites as the walk animation. I'm just going to play it at, let's say, double the speed. So we usually change the sample rate to 15. I'm going to change it to 30. We can see what that looks like. Go to our enemies folder in our sprites folder, and sprites 0 to 7 is our walk animation. Drag that in. Let's see what that looks like. That's maybe a little bit too fast. Let's try 23. It's a little bit fast, maybe just 20. Whoops, that's not 20. That's 20. That's a bit too slow. 23 was good, I think. Makes them look really rushed. Okay, cool. No, it's a bit too fast. We'll go with 21. Okay, so we're done with the animation window for now. Then we need to go to our animator. Here we have our charge state, and if we look at our state diagram, we go to charge state from our player detected state. So from our player detected state, we're going to make a transition to our charge state. Untick has exit time, set the transition duration to 0, add the two conditions. The first one, which is player detected, is false, and the second one we still need to create. It is a bool that we call charge, and then in the conditions set charge is true. Now we also need to make a transition back to player detected. And for that, again, untick has exit time, set the transition duration to 0, add the two conditions. The first one is charge is false, and the second one is player detected is true. So let's try this out. Let's go back to our scene view. I'm just going to move the enemy over to this platform where our player currently is. And actually, we should test to see if it actually works with the walls. I didn't actually check that. So let's see if that works. It should. It does. Okay, cool. Now, if the enemy detects us, it goes into the charge state, but it doesn't work. Oh, we forgot to add the charge state data. So let's go back to our scripts folder, enemies, enemy specific, enemy one, data, and then create a new data, state data, which we can't do yet because we forgot to add the code. Okay, let's come back to Visual Studio and then come back to our d_charge state. We need to add the create acid menu line at the top. So just come copy that from our move state. Like that. We'll set the file name to new charge state data. And the path is the same, except this needs to be charge, like that. Okay, now if we go back to Unity, we can right click, say create data, state data, charge state. And we'll call it E1_charge data, like that. Click on our enemy one game object and then drag our charge data onto the enemy. So if we run this now, when the enemy detects us, starts charging. Perfect. He does not detect the ledge, however. Oh, we did not put the conditions for that in yet. How long does he charge for? Our charge time is currently 2 seconds. That's a bit too long. Let's set this to half a second just to see if that part works. So he detects us, charges us, stops, go back to player detected. Perfect. Everything works just the way it should. Let's fix that. So in our code, let's go to our E1 charge state class. And before we do this if is charge time over statement, let's create another if. And in this if, we will say is detecting ledge. Actually, it's supposed to be is not detecting ledge. Or is detecting wall. Then in this case, we want to look for our player, but we don't have that state yet. So let's leave ourselves a little note over here, a little to do, and we'll say connect to look for player, like that. And then we need to change this to else if. We'll create the look for player state soon. If anything, we should probably do that before we do the attack state. Let's take another look at our state diagram. So we currently have this transition from player detected state here, and then we have a transition from charge state back to our player detected state. So before we do the attack state, let's do the look for player state. Because the attack state has a couple of extra things that we need to look at. We'll probably save that for a different video. Let's get this working. So let's go back to Unity and let's create all the files we need. So we'll start off by going to our states folder. Let's create a new C# script and we'll call it look for player. And I forgot to name it state again. Just add state, open it up in Visual Studio. Don't forget to add state here, like that. Okay, let's go to our data folder, create a new C# script, d_look for player. Let's open that up as well. And then finally, let's go to our enemy specific folder, enemy one, and then create a new C# script, E1_look for player state, like that, and open it up. So now before we forget again, let's go to our idle state or something and copy this and then paste it in our look for player state. And let's just fix this while we're here. Make it inherit from scriptable object, like that. Now we won't forget. Actually, we need to change this. So new look for player state. Look for player, like that. Perfect. Then let's go to our look for player state class, get rid of this, make it inherit from state, like that. And now let's generate our constructor. And then we can add our state data reference. So protected d underscore look for player called state data. Add it to our constructor. Like that. This dot state data equals state data. And then let's generate the overrides. So control full stop, generate overrides. We don't want the first three. Okay, perfect. Now let's just think about how we want the enemy to look for the player. Again, we're just going to keep this super simple. If the enemy is not detecting the player, we just want to keep looking in a certain direction for a bit of time, turn around, look in that direction for a bit, and then turn around again, and then transition to a different state. And of course, in that whole turning around thing, if we detect the player, we immediately go back to the player detected state. So let's start off by going back to our d look for player state class. And the two variables we're going to need for this class is the amount of turns that we want to do and the amount of time between turns. So the amount of turns is going to be a public int that we'll just call amount of turns, like that. And by default, we'll set it to 2. So that way, if the enemy is facing a certain direction, it'll turn, look behind it, and turn back the direction it was facing, and then continue whatever it was doing. Next, we want to create a public float that we'll call time between turns, like that. And by default, we'll just set it to, let's say, 0.75, like that. So in our look for player state, we want to keep track of if we are detecting the player in the minimum aggro range. So we'll declare a protected bool called is player in min aggro range, like that, and then do the check. So is player in min aggro range equals entity dot check player in min aggro range, like that. That is quite a mouthful. Anyway, next we want to keep track of whether or not we've done all the turns, and we also want to keep track of if we have done all the turn times. So let's declare 2 more bools. One is going to be called is all turns done, and the next is going to be called is all turns time done. So this one is just going to keep track of if we did all the turns. This one is going to keep track of the amount of time that has passed, basically. Next, in order to do the turns, we need to keep track of the time that we did the last turn. So we'll declare a protected float called last turn time, like that. And we'll also declare a protected int called amount of turns done. Now, another thing we might want to do in this look for player state is make it so that when we enter it, we turn immediately. So let's create another bool that we can set from outside, the same way we did with the idle state, flip after idle parameter, and create a protected boolean that we'll call flip immediately, like that. And now let's just create a public void function that sets this. So public void set flip immediately, and it'll just take in a bool that we'll call flip. Doesn't really matter. In this we'll say flip immediately equals flip, like that. So we can call this function from other states now to set that parameter. And then in our logic update, we'll take that into account to determine when we should flip. So let's look at our logic update function for this state. We want to say if flip immediately is true, then we're going to say entity.flip. We need to keep track of our last flip or turn. So we'll say last turn time equals time.time, like that. I don't like that I call this flip instead of turn, so let's just press Ctrl R twice on that, and we'll change it to turn immediately. Let's just change the function name as well from setFlip to setTurn, like that. Okay. And then back in if turn immediately, we want to say amount of turns done plus plus, because we did a turn. And then we want to set turn immediately equal to false. Otherwise, we're just going to keep coming back into this if statement. After this, we want to say else if, and in the if statement, we'll say if time.time is greater than or equal to last turn time plus state data dot time between turns and not is all turns done. So basically, if the current time is greater than or equal to the last time that we flipped plus the amount of times between flips, and we haven't done all the turns we're supposed to do, then we're basically going to again say entity.flip like that, and then last turn time equals time.time, and then amount of turns done plus plus. And that should take care of flipping the enemy. Next, we just need to see if we've done all of our flips. So we'll say if amount of turns done is greater than or equal to state data dot amount of turns, then we want to set all turns done equal to true, like that. Now to make it so that after the enemy does his final turn, he looks in that direction just for a little bit before going back to whatever other state we choose, we'll say if time.time is greater than or equal to last turn time, again, plus state data dot time between turns and is all turns done is true. So that means we've done our final turn. Now we just need to wait for one more turn time and then we can transition. So here we'll say is all turn times done equals true. And we'll use this is all turn times done Boolean to determine when we transition. So that should be it for the look for player state. Let's come to the E1 look for player state. We can get rid of this code, make it inherit from look for player, like that. Then we can generate the constructor, get the reference to our enemy, so private enemy1 called enemy, add it to the constructor, enemy1 enemy, this dot enemy equals enemy, like that. Generate the overrides, like that. We should all start becoming experts at this. And now in here, basically all we're going to say is in the logic update, if is player in min aggro range, so we're looking for the player and we detect him, we'll say state machine dot change state to enemy dot player detected state, like that. And then we'll say else if, scroll down, so else if our is all turn time done, then state machine dot change state to enemy dot move state, like that. So our enemy is going to look around for our player. If he finds the player, we'll go back to the player detected state. If he doesn't find the player, he will just start moving again. Perfect. Now we just need to go back to our enemy1 class and add this state. So up here, we'll say public E1 underscore look for player state, and we'll call it look for player state. Get the public getter and the private setter, like that. And then we need the reference to the data. So we create a serialized field that is a private D underscore look for player data. And we'll just call it look for player state data, like that. Then in our start function, we can call the constructor to create the instance. So look for player equals a new e1 underscore look for player state, and the entity is this. The finite state machine is state machine. The animation boolean name is going to be look for player with a lowercase l. State data is look for player state data, and the enemy is also this. So now, before this is going to work, we also need to set up the transitions from our other states to our look for player state. So let's pull up the state diagram again. And so this state diagram is a little bit outdated. We're actually going to make a transition from player detected to look for player state if we leave the range. And then we're also going to make a transition from charge player state to look for player state if we no longer detect the player. So let's start with the player detected state one. So let's go to our E1 player detected state, which is here. And so after this if, we will say else if not is player in our max aggro range, then state machine dot change state to enemy dot look for player state, like that. And then in our charge state, so E1 charge state, let's get rid of this to do, and then we'll say state machine dot change state to enemy dot look for player state, like that. So now we can go back to Unity, and then in our animator, we don't have a specific animation that we're going to use for this. We're just going to reuse the idle animation. So we can just right click in the animator and create a new empty state, and we'll just change the name to match everything else. So we'll say enemy one underscore look for player, like that. And then under the motion, we can just click on the circle and select our enemy one idle animation as this animation. Now let's add the parameter. So we're adding a new boolean, and this is going to be called look for player, like that. Okay, so now let's set up the transitions. We want a transition from our player detected state to our look for player state. Click on it, untick has exit time, set the transition duration to 0, add the two conditions. The first one is player detected is false. The second one is look for player is true. And then we need to transition from this back to player detected. Untick has exit time, set the transition duration to 0. Add the two conditions. The first one is look for player is false. The second one is player detected is true. Next, we also want to transition from our charge state to our look for player state. And then we want to untick has exit time. Transition duration is 0. Add the two conditions. The first one is charge is false, and the second one is look for player is true. And now we just need to remember to add the data to our enemy. So let's go back to our scene view, click on our enemy one game object, then go to our data folder, right click, create data, state data, look for player state, and we'll just call it E1 underscore look for player data, like that. Click on enemy one, and then just drag this into our slot. So now when we run the game, when the enemy detects us and we leave, as you can see, the enemy turns and then breaks. Let's figure out why. So we're currently still stuck in the look for player state. Oh, okay. So we're still missing a transition from our look for player state to our move state or our walk state. So we'll make a transition from look for player to our walk. Untick has exit time. Transition duration is 0. Add the two conditions. The first one is look for player is false, and the second one is move is true. So if we run the game now, the player detects us and he starts looking. Okay. So currently the enemy flips immediately, which is not quite what we want. Let's figure out why. So if we go back to our look for player state class, we forgot to add everything to our enter function. I'm a big dumb. Okay. So in our enter function, we need to start off by setting the booleans to false. So is all turns done equals false. Is all turns time done equals false. And then we need to set our last turn time equals start time, like that. And then our last turn time equals our start time. And then amount of turns done equals 0. And then finally, we just need to set the velocity to 0 just in case. So entity.set velocity to 0f, like that. Okay, now if we go back to Unity and run it, this should work. So as you can see, the enemy looks in one direction a little bit first before he flips. There he chases after us, and he stops at the ledge and looks for us. Perfect, everything is working beautifully. I'm going to end this part here. So we currently have our idle state, moving state, player detected state, charge state, and look for player state. So next we're going to make it so that our enemy can actually attack us, and then after that we'll probably look at how we can stun the enemy and then eventually kill the enemy. So as it is right now, we can't actually hurt the enemy like we could before. Nothing happens when we hit it. We just have a error saying that our send message has no receiver, which is fine. So that's it for this episode. I hope you guys are enjoying this as much as I am. This is really exciting for me. I had so much fun creating all of this. I learned so much new doing all of this. I'm sure I'm still doing some things that can be done in way more efficient ways, but this is a huge improvement over how I was planning on doing this, and it's awesome. So I hope you guys are enjoying it, and I would just like to give a big thanks to my supporters and wonderful people on Patreon. You guys mean so much to me, and a huge thanks to Lewis for your support, and I hope all of you have a wonderful day.